So the last lecture we have worked out drawing the network has been constructed, but this lecture we are going to identify the critical path and also the free floats and total floats. So continuously we are going to organize these three questions in this particular problem. So here the problem number 1, the activity has given and the predecessors has given and the duration will be given. So has been given. So now the activity A, B, C, D, E, F up to N and the predecessors for A and the duration has been given. So the first question, construct the CPM network, and the second question, determine the critical path and project completion time, and the third question, compute the total floats and free floats for non-critical activities. So the activity here, the first question, construct the CPM network. So for the CPM network, so here the activity started from A and there is no predecessor for A, and there is a B, activity B, there is no predecessor for B, and there is a activity C, there is no predecessor for C. So for these three activities we don't have any predecessors. It starts from the initial node. The initial node here we have mentioned as this is 1, and so this is 1, and from the 1, so we have an activity 2. I mean from the 1 to 2, the node 2 will be the A activity has been done. So A and the duration will be mentioned, that is 2. So here the duration will be has been 2, and the activity from B from 1 to 3. So the second node has been initiated, and then the third node which is 3 and the activity B and the duration which is 5, and the activity C from the node 1 which is the C activity through the node 4. So from the node 4, so the duration which is 4. So therefore C of 4. So there is a 3 activities simultaneously we are doing in this drawing. So after that, so we have an activity D through the table. You can just see here through the table. So here D and the predecessor B. So immediately we have a predecessor B, and we can check through the table if there is any predecessor for B. So here there is a predecessor B, and for the activity G. So from the B we have two activities are going here. So through the two activities we are going to take two nodes are there, but there is a activity, there is a node 3. From the node 3, so we have an activity D is there. So through the D, so already the D is activity, so the duration 4 is here. So through the D, so we have to draw a activity to 4. So this is what here, and 3 to 4. So the activity has done through the fourth node, and again, so the node 1 and node 2 and node 3 and node 4 has been completed. Now the node 5. So before node 5, so the activity E is being taken, and the activity E from the predecessor A. So from the predecessor A, which is, so we can just draw this line and to the node which is equal to 5. So and the duration has been mentioned as E of 7. And one more activity F, the F is also coming from the predecessor through A. So that is what from the 2. So we have to draw another node, that is 6. And from the 6, so we can just draw this line, and first of all we have to draw this line, and second thing is draw this line, and we can put it this 6th node. But again, so we have an activity G. So through the G, it is coming from the predecessor B. So we start from B through the third node to 6th node. So that is the duration G of 3. So that is the duration G of 3. So here, and the next node, it starts from H. The next node the activity which is H, and it start from C and D. It start from C and D, 4 to 6, and this is H, and the duration which is 6, duration C H of 6. And the next activity which is I, it comes from the predecessor which is comes from C and D. So here it is C, and here it is C, and here it is D. So we have to draw the activity from node from 4 to 4 here it is I. So I of the duration 2. So here we have written here. So this is the node 7. So we have completed node 1, 2, 3, 4, 5, 6, 7. So already we have completed, and E has completed, activity E has completed, activity F has completed, activity G has completed, activity I has completed. So 5, 6, 7 nodes are completed. Now we are going to take up the next activity which is J. So through the jth activity, the predecessor which is E. So here it is E. So the predecessor E from the node 5. So we have to draw a activity J and the duration 5. So we have to draw this line, and it is noted as 8. And again from the already we have completed 7th node, and now we have to draw the 8th node. Now the next activity which is K, and the K from the predecessor which is F, G, H. There are 3 activities of the predecessors for the kth activity. So through the kth activity already we have F, G, and D will be F, G, and H will be there. So from the 6th activity, so we have to draw a kth activity here through the 8th node. So the 8th node will be here, and the kth activity and the duration which is 4. So now the the activity L, and again the L has been taken from the predecessor which is F, G, H, again from the 6th node. So we have to write the Lth activity, the duration which is 3. So that is here 6 to 9. So the activity which is 9, and again there is a activity M, and predecessor which is start from I. So and already we have mentioned the 8th activity, and we have now the 8th node will be there, and the 9th node will be here. So now the activity M, and through the activity M we have the predecessor which is I. So therefore, so from the I, so it is from the node 7, and we are just draw the activity which is M, and the duration which is M of 12. So this is 9th node, and now the final activity which is N, and through the nth nth activity. So the predecessor which is comes from J and K. So there is a J, so up ended with the 8th activity, 8th node, and there is a K ended with the 8th node. So from the 8th node we have to draw the one more activity, so to the 9th node. So that is N, and the duration which is mentioned as 8. So these are all the network. So we are first constructing the network here. The next thing is we are going to find out the critical path now. So for the first question, so construct the CPM network. So now we are constructing the CPM network here. So the to find the critical path from node 1 to 9 is the second question. So through there are 3 possible paths from the this network. So here the drawing is here. So through the 1, 2, 3, 4, 5, 6, 7, and 8, 9. So these are all the nodes are here, and there are 3 paths are here. So one is 1, 1, 2, 5, and 8, 9, and the another path is 1, 2, 6, 8, 9. The third path is 1, 3, 4, and 5, 6, and 8, and 9. So these are all the 3 paths are here, but there are 2 phases to find the critical path here, because there are 2 formats already we were discussed in the last lecture, and through the PDF, through the PPT, so we have discussed, and determine the earliest start time, that is ES. So ES has been calculated of all the nodes. This is called forward pass method. So already we were discussed in the last lecture. So and the second phase is determine the latest completion time, that is LC, of various nodes. This is called the backward pass method. So for the forward pass method, this is the formula ESJ, which is equal to maximum of ESI plus DIJ. That is the earliest start time plus the duration. Earliest start time plus the duration. And if there is a two activities are here, so we can choose the maximum value of the two activities. This is what we are going to do in this particular drawing, right? So here we have taken two boxes for this every activity. So here there is 0 and 2, and here it is the third activity and the fourth activity we have, and then fifth activity and the sixth activity, the sixth node, and there is a first node, second node, third node, fourth node, fifth node, sixth node, seventh node, and the eighth node and the ninth node. So from the first node, it is a yearly start time which is started with 0. There is no initial value, so there is initial value start with 0, and up to the next activity, the yearly start time which is 0 plus the duration. 0 plus the duration. So there is only one activities here for 1 to 2. So 1 to 2 we have only one activity, and there is one duration. So therefore 0 plus 2 we have 2, and there is a 1 to 3 activity from 1 to 3 node. So we have a duration here 0, 0 plus 5, here it is 5, and there is an activity C from node 1 to 4. So we have a early start time, here it is 0 and plus 4, so which is 4. So here it is 0 plus 4. So then we have mentioned the next activity which is comes from the second so node 2. So node 2 equal to 5, node 2 equal to 5, and node 3 equal to 5, and node 2 equal to 2, and node 3 equal to 5, node 4. There are two options, E14 and E34. So there is a E34 and there is a E14 is there. So 3-4 and then 1-4 is there. So here it is 1-4 and 3-4 is here. So through the two options, we choose the maximum of above two. So here it is E4 is maximum of the first calculation, which is 4, and the next calculation. So the duration will be adding here. So 5 plus 5, so which is equal to 10. So the maximum calculations, one is 4, the another one is 5 plus 5. So 4 comma 10. So we can choose the maximum value which is equal to 10. And similarly, we have to identify all the nodes of values. So you can just see here from the node from 2 to 5. So there is a yearly start time which is here 2, and here it is 7. So 2 plus 7, here it is 9, and here it is 2 plus 3. Already we have 2, and here it is 3. But there is an activity for 6. There is a node 6. So we have three options. Three options are there. So we find the maximum value. So here it is 2 plus 3 5. So and 5 plus 3 8, and here it is 10 plus 6 16. So we can choose the maximum. So that is 16. So here it is 16. And the seventh node, we have only one activity. So there is a yearly start time, here it is 10 and plus 2, so which is equal to 12. And from the eighth node, so from eighth node, there is only one activity. So from here it is the yearly start time, it is 9, and 9 plus 5 equal to 14. And there is a one more activities here from 6 to 8. There are two options. We can choose the maximum of two options. So this is what node 8. So 28 minus 8, 20. Node 7, it is 16. Already we were discussed. And node 6 are 16. And node 8 to 7 to 9 there is a early start time which is 12, and here it is 28. So there is a two activities, or there is a three activities. So from the node 8, so we have two early start time. So 9 plus 5 and 16 plus 4. So the maximum value which is 20, and so we can choose the 20. And there is a ninth node. So through the ninth node there is an activity from node 8, node 6, node 7. We can choose the maximum of these three. So here it is 19 plus 5. So here it is 20 plus 8, 28, and here it is 16 plus 3, 19, and here it is 12 plus 12, 24. We can choose the maximum, that is 28. So this is what the constructing of the early start time. So the early start time, it was mentioned as ES. And latest completion time, the same kind of work has been completed through the latest completion time. Here it is the latest completion time. It's a minimum of that LCJ minus DIJ, that is duration. So LCJ means it is the latest completion. Here it is the latest completion, which is 28. So from the 28 there are three options are here from the to the node 8. So the latest completion, which is 28, there are three options are here. We can choose the minimum of those three. And here it is 28 minus 8. So we have taken the LCJ, which is 28, and we can choose the duration. Here it is 8, and here it is 3, and here it is 12. So 28 minus 8, here it is 20, and 20. So here, so we are identifying the node 8. So here it is only through this node, and we can choose the 28 minus 8, which is 20. And through the node 7 there is only one latest completion time, 28 minus 12. So 28 minus 12, which is equal to 16, and 7 has completed, 8 has completed, and now 6. So from the 6, the latest completion activity, there are two options are here. So we can choose the minimum options. So from the 28, so 28 minus 3, and 28 minus 3, and then 20 minus 4. So 20 minus 4, 28 minus 3, we can choose the minimum, it is 16. So we can choose the minimum 16 result. So here it is, the node 16 is 16. Latest completion time on the upper box. So it is the 16. Now from the fifth node, so we can choose the one activity from the eighth node. So 20 minus 5, so which is equal to 15. So it is the upper box. The latest completion time for the fifth node, it is 15. Now from the fourth node, so now already we have completed 9th, 8th, 7th, 6th, 5th. Now we can choose the fourth node. So for the fourth node, we have two activities are here. The two activities are here. So we can choose from the 16 minus 6 and 16 minus 2. 16 minus 6, so and 16 minus 2. So therefore 16 minus 6, it is a minimum value 10, and here it is 16 minus 2, it is 14. So we can choose the 10 is the minimum value for this latest completion time. So for the fourth one, 10. And for the third one, so we have, there are two options are here. We can choose the minimum value. We can choose the minimum value. So from 10 minus 5, 5, and 16 minus 3, which is 13. So and we have to choose the minimum value, that is equal to 5. So the latest completion time, which is 5. So from the third activity has completed. Now the second activity, second node, the second node. So we have to get the value from fifth node, and there is a sixth node. There are two options are here. From the two options, we can choose the minimum value. So one is 15 minus 7, and the another one is 16 minus 3. So we can have the minimum value, which is equal to 8. So finally we can just conclude the node 1. There are node 1, we have three options are here: this activity, and this activity. So here it is 10, and here it is 5, and here it is 8 or the latest completion time. So 8 minus 2, and 5 minus 5, and then 10 minus 4. So there is a, we wanted to get the minimum value. So here it is 0. So 0 is the latest completion time. So this is the critical path. So from this diagram we can get the critical path. So if we have a same value, so we have some procedure to follow this critical path. So here ESI equal to LCI. So and ESJ which is equal to LCJ, and the difference of early start ESJ minus LCI and LCJ minus LCI, so which is equal to the duration value. So this is what in the this structure. So there is a latest 0 and 0, there is a 5 and 5, and there is 10 and 10, and there is a 6th node 15 and 16, and there is the 9th node, there is 28 and 28. So we have to draw a double line here, and we can get the path, that is 1 to 3 and 3 to 4 and 4 to 6 and 6 to 9. So from the last critical path, so we have to draw the critical path here, that is through the activity B, D, H, K and N. So now we can just calculate the duration. So the total duration of the activity which is equal to the project completion time. So for the duration for the B which is equal to 5, and D which is equal to 5, and H which is equal to 6, and K is equal to 4, and N is equal to A. So we can just add these values and we can get the project completion time which is equal to 28. So this is what we have done through the critical, we are finding the critical path here. Now the third question is to find the total float and free float through non-critical activity. It is the amount of time that the completion time of an activity can be delayed without affecting the project completion time. So this is what the total float formula. So TF which is equal to LCJ minus ESI minus DIJ, and the total float, that is equal to LCJ means it is the latest completion, and the ESI means it is the earliest start time, and the D means it is the duration of the activity, specific activity. So for the free float, so we have the definition of the free float. It is the amount of time that the activity completion time can be delayed without affecting the earliest start time. So here the free float formula, ESJ minus ESI minus DIJ, the duration. Now we can so through this diagram, so we are going to find out that free float and the total float. So here through the table we are calculating the total float and free float. Already we have the formula. So through the activity, so the A activity, it is the A activities from the node 1 to 2, and the B activity from the node 1 to 3. Already we have through the network we have the values of the durations 2, 5, 4, and every activities have the same durations. So we have up to 8, and the total float which is equal to, so through the formula, so here it is so here the total float for through the formula. So we have through the drawing we can just get the result. So here it is the total float, we can just see through the activity A, that is activity A 1 to 2, from the node 1 to 2. So here it is 1 to 2, we can just take the earliest starting time 0, and there is a duration which is equal to, so the earliest, I mean the latest completion time which is equal to 8. So here it is 8 LCJ minus the earliest start time minus the duration which is equal to, so 8 minus 2 which is equal to 6. So 8 minus 0 minus 2 which is equal to 6, the first value. And the B activity, there is a node from 1 to 3. So here through the 1 to 3 we have the latest completion time which is 5. Latest completion time which is equal to 5. So 5 minus 0 minus 5, so which is equal to 0. So this is what done here, the total float 5 minus 0 minus 5 equal to 0. The same way we are calculating through the diagram. So here it is that latest completion time 10, and minus 4, I mean minus 0, minus 4, so which is equal to 6. So that is what the table, through the table we have 6. And there is a activity from 2 to 5. So the activity from 3 to 4, there is a D value. So here it is 10, the latest completion time, which is 10, and the duration, I mean the latest completion, earliest is it is 5, and minus 5, so which is equal to 0. So 10 minus 5 equal to 0. And the same way we are calculating through the diagram. So through the activity, the total float which is equal to 6. For the F the activity, the total float which is equal to 11. And total float which is equal to the total float for the G activity which is equal to 8. And the total float for the activity H which is equal to 0. And the activity for I, the total float which is equal to 4, and J which is 6, and K which is 0, and L which is 9, and M which is 4, and the final N, the node which is equal to 0. So we can just take up the value. So wherever the 0, so here N, and there is K, and there is H, and there is a D, and there is B for the total float. Now we can calculate the free float. So through the formula, here it is ESI, that is yearly start time, minus ESJ minus ESI, the duration. So through this formula, through this diagram, so we can calculate the format. Here it is the free float which is equal to. So the free float which is equal to, so the value 2 minus the later, I mean here it is the yearly start. So in the previous stage we are taking the latest completion. Now we are taking the earliest starting time. So 2 minus 0 minus 2, which is equal to 0. And then the next activity 1 to 3, we have 5 minus 0 minus 5, which is equal to 0. So this is what the second free float on the B activity B. For the activity C, so we can do the same process for 10 0 4, which is equal to 6, 10 5 5, which is equal to 0, 9 minus 2 minus 7 equal to 0. For the F activity, it is 11, activity G, which is 8, and activity H, which is 0, and activity I, which is 0, and activity J, which is 6, and activity K, which is 0, and activity L, which is the free float 9, and activity M, the free float which is 4, and activity N, the free float is 0. So any critical activity will have 0 total float and 0 free float. So any critical activity will have 0 total float and 0 free float. Based on this property, we can determine the critical activities. So here so here we have find out the third question, that is compute the total floats and free floats for non-critical activities. This is what we have done in this particular table. So this is the first problem, and the next problem, it is based on the PERT. The next problem, it is based on the PERT. PERT means already we have defined the PERT. It is a program evaluation and review technique. So here there are activities, or the same activity will be there, but there is a duration has been classified into different procedure, that is optimistic time and the most likely time and the pessimistic time. So each activity will have 3 time estimates, and the optimistic time, most likely time, and pessimistic time. So that is OMP. So from the above, we find the expected time duration and the variance of the project. So this is what the PERT. So through the expected time duration, we have the formula. Here it is TE, expected time, which is equal to TE. So T naught plus 4 TM minus TP divided by 6. and the variance which is equal to Tp minus T naught divided by 6 the whole square. So this is what the variance. So the first problem, consider the following table summarizing the detail of the project. So here there is an activity, and for the activity there is a predecessor, but the duration for this part there is a optimistic time, there is a most likely time, there is a pessimistic time. So here it is O, M, P. So through this table, first we have draw the network, and then we have to calculate the expected time duration, and then we have to calculate the variance. So this is what the question. So construct a project network, and the second question, find the expected duration and variance of the each activity, and the third question, find the critical path and expected project completion time, and the fourth question is what is the probability of completing the project on or before 22 weeks. So they have mentioned some weeks, so we find out the weeks, and through the fourth question we find out the probability. For the first question, we have to construct the project network. So we can just draw the network here. So from the activity, so there is an activity A, B, C. There is a nil predecessors. So we start from node 1. So start from node 1. So we have to draw the node 1, and node 1 to 2 it is A, 1 to 3 it is B, 1 to 4 it is C. Then the next node D, it is the predecessor of A. So therefore through the second node to fifth node, already we have completed the first node, second node, third node, fourth node. So from the second node, from the activity A, so we have a predecessor. For the activity D, we have a predecessor of A. So we have to draw a activity from 5. So this is denoted as 5, and then it is D. Now the next activity, which is E, it is the predecessor of E, the predecessor which is B. So, and if there is any B, there is no B, so we can just draw a network from B. So here it is, the E will be happen. So this is activity, the node is 6, and the next so the next activity, which is F, and there is a predecessor C, and there is one more predecessor C for the activity G. So for the C, from C we have to draw the network for the node for activity which is F and G. So here from the sixth node, so already we have the sixth node from E, and we have to draw the network for the sixth one, it is F, and the another one is G. So it should be a seventh one, the seventh node will be here. So you can just see here, there is a node from D. So already the predecessor of node D, which is from I. So this is what we have draw the network from here, it is I from 5 to 8, and then the fourth node, from the fourth node to sixth node we have an activity F. So through the seventh node, so we have an activity from the sixth one, it is H, and from the fourth node, which is G. So already we have defined the fifth node to eighth node, so that is I, and finally we can just conclude the activity which is J, which is the predecessor of the J predecessor H and G. So here it is, H and G will be from the seventh node. From the seventh node to eighth node, we have to draw the activity J. Now this is the project network, and the second thing is we are going to identify from the duration OMP. So from for calculating the expected time duration and the variance. So here the formula, the mean duration, that is TE, already we were defined this formula, and we have OMP, the duration has been there. So through the formula 5 plus 4 into, so here it is 4 into Tm. So 4 into Tm and plus minus Tp, and then divided by 6, whole divided by 6, we have missed here it is 6, divided by 6, which is equal to 6. And the same way we are calculating the another mean durations of all the activities. Here it is second one 3 and 4 and 2 and 3, 5. For the corresponding G it is 3 and H is 3, and finally we can conclude J it is 3. And variance, so the variance, so through the formula it is Tp minus T naught divided by 6 the whole square. So so divided by 6 the whole square, and through the formula we have to get the value. Here it is Tp is there and minus T naught is there, divided by 6 and the whole square. So it will be taken, it will be identified as 0.011, and simultaneously we can calculate all the activities up to the jth activity. So to find the critical path and the expected project time. So we are completing the first question is draw a network. So constructing the network. The second thing is we are identifying the expected time duration and the variance, and the third question is to find the critical path. So through this critical path already we were discussed the critical path to find the phase 1 and phase 2 through the early start and the latest completion time. So through this formula we are identifying here there is a early start which is equal to 0, and here it is the early start 0 plus 6 which is equal to up to 6. I mean from the one activity from node 1 to 2 it is 6, and node 1 to 3 that is 0 plus 3 which is equal to 3, and node 1 to 4 there is an activity 0 plus 4 which is equal to 4, and activity D which is node from 2 to 5, the early start time which is equal to 6 and plus 2 which is equal to 8, and the activity E start from 3 to 6 and here 4 to 6. There are two options are here, so we can choose the any one options. We can just find the maximum of these two options. So here it is 3 plus 3 which is equal to 6, and here it is 4 plus 5 which is equal to 9. So we can choose the maximum, it is 9. So therefore 9 is the early start time for the 6th node. And the 7th node there is a two options are there. So one is from 6 to 7, the another one is 4 to 7. From the 6th one it is 9 plus 5, it is 9 plus 5 which is 14, and here it is 4 plus 3 7. So we can choose the maximum, it is 14. Now 14 has completed, it's a yearly start time, it is 14. Now the next node which is start from 5 to 8, 5 to 8 which is the early start time which is 8, and there is only one activity. So 8 plus 5 which is 8 plus 5, and there is another one activity, there is another one options are here. There are two options for 8, one is 5 to 8, the another one is 7 to 8. So we can choose the maximum, one is 8 plus 5 that is 13, and the another one is 14 plus 3 17. So we can choose the maximum which is 17. So this is the yearly start time. The same way we are calculating the latest completion time. So through the every node and the activity, each node and the activity. So here it is 17, and here it is 14, and here it is 12, and here it is 9, and here it is 6, and here it is 4, and here it is 10, and here it is 0, or the latest completion time. Through the latest completion time, through the earliest start time, so we can just find the critical path. If the two options are equal, so we can just take the first node and the fourth node and the sixth node and the seventh node and the eighth node will be the same values, and the durations are difference are taken from the early start time and the latest completion time. So finally we can just conclude these three conditions are satisfied. Then we have to conclude the path is 1 to 4 to 6 to 7 to 8. So 1 to 4, 4 to 6, 6 to 7, 7 to 8. all the above conditions are satisfied. Now the expected completion time for the duration for 1, which is 4, and the fourth node, which is the 5, and the 6, which is 5, and so, I mean the fourth one is 1 to 4, which is the 1 to 4. So here it is 1 to 4. There is a result. So there is a C. So for C, F, and H and J. C, F, H, J. So 4, 5, 5, 3. 4, 5, 5 plus 3 equal to 17 weeks. So this is what the project completion time. And the next question, so we find the probability of the completion of the project on or before 22 weeks. So we have an activity already, C, F, H, J are the path, and the duration will be 4, 5, 5, 3. Now we can get the variance. Already we have the variance value for this particular activities. So this is 1 and this is 1.78, this is 1 and this is 1, and this is a sum of all these durations and the variance. Here it is the duration, which is 17, and the variance, which is equal to sigma square. So sigma square, the standard deviation has been completed. Through the standard deviation we can just calculate the variance. Here it is 2.19. Now but the question is probability of the completion of the project on or before 22 weeks. On or before 22 weeks. So probability of X is less than or equal to 22. So we can take the Z value. So through the Z value, Z is less than or equal to that 22 minus 17. Here it is X bar, which is equal to 22 weeks, and mu, which is equal to the duration, sum of the duration, which is equal to 17, and the sigma value, which is equal to 2.19. So the probability of Z is less than or equal to 2.28. Now through this particular probability value has been calculated through the standard normal table value. So this is 0.9887. Through the standard normal table value we can calculate this particular value.